Carving a mountain into a functioning building is an exercise in subtractive engineering that leaves absolutely zero room for human error. In traditional masonry, if a stone block is damaged, it is simply discarded and replaced. But when an entire architectural complex is monolithic, hewn from a single continuous piece of the Earth's crust, a single chisel strike that goes too deep permanently alters the structure. There is no adding material back. Despite this unforgiving reality, in the 8th century, artisans in the Maharashtra region of India successfully removed an estimated 400,000 tons of solid volcanic basalt to reveal a structure of unprecedented complexity. This is not a building that was constructed. It is a building that was excavated. Today, we will conduct a detailed architectural and historical analysis of the Kailasa Temple at Ellora. We will examine the geological properties of the rock, the precise top-down excavation techniques employed by the Rashtrakuta dynasty, and the logistical realities of executing one of the most ambitious engineering projects of the ancient world. Before we examine the specific dimensions and construction phases of this monolithic marvel, please consider subscribing to the channel. We explore the factual engineering and historical contexts behind the world's most remarkable structures every week. The Kailasa Temple is officially designated as Cave 16 within the Ellora Caves complex, a UNESCO World Heritage Site featuring 34 monasteries and temples carved side by side into the wall of a high basalt cliff. While the surrounding caves are undeniably impressive feats of rock-cut architecture, they are essentially horizontal excavations, tunnels driven into the rock face. Cave 16 is fundamentally different. It is a freestanding, multi-story temple complex exposed to the open sky, standing within a massive excavated U-shaped courtyard. To understand the engineering required here, one must first understand the medium, the Deccan Traps. The Ellora Caves are situated in a region defined by massive volcanic formations. Millions of years ago, widespread volcanic activity laid down thick layers of basalt. Basalt is an extrusive igneous rock, known for its density, hardness, and durability. It is incredibly difficult to quarry, let alone carve with intricate precision. Yet, this was the canvas chosen for the Kailasa Temple. The temple is designed to represent Mount Kailash, the mythological Himalayan abode of the Hindu deity Shiva. To replicate a mountain, the architects decided they needed to literally carve it from one. The sheer scale of the excavation requires a careful breakdown. The central courtyard is approximately 276 feet long and 154 feet wide. The main tower, or shikara, reaches a height of nearly 100 feet from the base of the excavation. To create this open space and the freestanding structures within it, surveyors and engineers had to execute a flawless, top-down excavation strategy. The process began at the very top of the sloping hillside. Surveyors would have had to map out the exact footprint of the massive U-shaped trench that would isolate the central block of rock. 3 deep trenches were dug vertically downward into the basalt bedrock. As they dug deeper, they were essentially freeing a massive rectangular monolith in the center of the pit. Once the central block was isolated, the subtractive carving of the temple itself began. The artisans worked methodically from the roof down to the base. They first carved the intricate finials and the domed roof of the shikara. As the surrounding trench grew deeper, they carved the upper levels, the balconies, the structural pillars, and finally the plinth and the lower foundation. This top-down method provided a distinct structural advantage. It eliminated the need for scaffolding. The unexcavated rock itself served as the platform for the workers. However, it also demanded absolute spatial awareness. The chief architect, or stapati, had to possess a complete 3-dimensional blueprint in his mind. Every gallery, interior chamber, stairwell, and sculptural relief had to be anticipated and aligned before the rock around it was removed. Let us consider the historical and temporal context of this project. Epigraphical evidence, specifically copper-plate inscriptions, attributes the commissioning of the Kailasa Temple to King Krishna I of the Rashtrakuta dynasty, who reigned from approximately 756 to 773 CE. If we accept that the bulk of the excavation was completed during his roughly 18-year reign, the mathematics of the labor force become staggering. Removing 400,000 tons of basalt in 18 years translates to removing roughly 22,200 tons per year, or about 60 tons every single day. This level of productivity was achieved using exclusively manual labor. The primary tools available in 8th century India were iron chisels, heavy rock-breaking hammers, and pickaxes. Metallurgical analysis of tools from similar ancient Indian sites indicates that the iron used was of high quality, frequently forged and tempered to withstand the brutal impact against solid basalt. Workers likely used a technique of cutting small channels into the rock, inserting wooden wedges, and soaking them with water. The expanding wood would cause the rock to fracture along natural fault lines, allowing for the removal of larger blocks before the finer detailing work began. But digging the rock out is only half the logistical equation. The other half is material disposal. Where did 400,000 tons of volcanic rubble go? Unlike traditional construction sites that leave behind clear geological footprints, the immediate vicinity of Ellora does not feature massive spoil heaps proportional to the excavation. The most widely accepted academic theory is that the excavated basalt was not treated as waste, but as a resource. The quarried blocks and rubble were systematically transported away and repurposed for constructing other regional infrastructure, retaining walls, civil buildings, and fortifications in nearby Rashtrakuta settlements. This implies an incredibly organized supply chain functioning in tandem with the excavation effort. Beyond the raw excavation, the Kailasa Temple is renowned for its sculptural complexity. The temple is not just a building, it is a library of stone. The base of the main temple is elevated on a massive plinth, famously supported by a frieze of life-size stone elephants, appearing to bear the weight of the entire structure on their backs. The exterior walls are adorned with extensive narrative panels detailing scenes from the two major Hindu epics, the Ramayana and the Mahabharata. These panels are not merely decorative. They were carved with a deep understanding of light and shadow, designed to be legible and dramatic as the Indian sun moved across the sky. Furthermore, the temple complex features a sophisticated rainwater harvesting and drainage system. Carving deep into a rock basin creates an immediate flooding risk during the intense Indian monsoon season. The engineers anticipated this. They incorporated subtle slopes, stone channels, and gargoyles to direct massive volumes of rainwater away from the foundation and out of the courtyard, ensuring the structural integrity of the monolith over centuries. The resilience of monolithic architecture was dramatically tested in the late 17th century. Historical records indicate that the Mughal Emperor Aurangzeb, driven by ideological differences, ordered the destruction of several Hindu temples, including Kailasa. According to accounts, a force of 1,000 workers was dispatched to dismantle the structure. In a traditional building of masonry and mortar, dismantling is a matter of removing the keystone or undermining the foundation. But Kailasa has no joints. It has no mortar. It is a single extension of the earth. The Mughal workers spent 3 years attempting to destroy it, utilizing pickaxes and fire-setting techniques. Ultimately, they were only able to deface some of the statues and cause superficial damage to the exterior before the effort was abandoned. The sheer density and continuous nature of the basalt rendered the temple virtually indestructible to conventional demolition methods of the era. Today, civil engineers view the Kailasa Temple as a masterclass in structural planning. While modern technology, such as heavy explosives, diamond-tipped excavators, and pneumatic drills, could certainly remove the required volume of rock much faster than the Rashtrakuta workforce, the actual reconstruction of the temple's intricate details using the top-down monolithic method would remain highly complex and prohibitively expensive. Modern architecture relies heavily on the addition of modular components. We assemble steel beams, pour concrete into forms, and rivet panels together. The ancient Indian artisans utilized the exact opposite paradigm. They saw the finished structure hidden within the mountain and possessed the patient, generational discipline required to liberate it. The Kailasa Temple stands not as a product of mysterious lost technologies, but as a profound testament to what human manual labor can achieve when guided by advanced geometric planning, deep geological understanding, and an unwavering, unified vision. It reminds us that ancient engineering was not primitive. It was simply utilizing the resources of the earth in a fundamentally different and arguably more enduring manner. Thank you for joining us on this detailed exploration of the Kailasa Temple. If you found this architectural and historical analysis valuable, please let us know your thoughts in the comments section below. Do you think modern society still possesses the patience for such generational monolithic projects? Share your perspective and make sure to subscribe for more factual deep dives into the engineering of the past.